Hello everybody and welcome to your video notes on Learning Target 3.5 at the basic level. And we're talking about free fall distance this time. So there's another video out there that helps us find V2. Remember that if something is dropped, like you can kind of look ahead at our example here, and an apple falls from rest. So for all of these, V1 is going to equal 0, and for all of these, A is going to be negative 9.8 meters per second squared. Because whenever we're doing something with free fall, that's a big hint that we're going to be using that for our acceleration. So go ahead and copy down this question into your notes. Pause it if you go ahead. So go ahead and pause it because I'm just going to keep going here, but you should have this step written down. I guess I should back up a little bit. The equation that we're going to be using is this. Distance equals v1 times t plus 1/2. I got this. 1/2 times acceleration times time. Hey, look at that beautiful equation. So if we focus on this a little bit, we can kind of break it down here. So let me try this again. So, and then this is squared. Very important idea. Pay close attention to order of operations. Make sure that you follow what you're doing here. Don't add before you simplify what's on the left and the right. This part right here, we can cross out when V1 equals 0. Because 0 times 300 or 0.5 doesn't matter. This will go away. So we'll mostly be focused on this. Another hint is that I will only give t in these problems. So you have to remember that a equals negative 9.8 meters per second squared, and that v1 equals 0. Okay, so you have to remember these things when you're doing this problem. Okay, so if you come over here now, so we're going to use this equation. The d equals v1 times t plus 1/2 times a times t squared. Okay, so we're going to have d equals, so we're doing our givens and unknowns. D equals, v1 equals, t equals, and a equals. So d equals a question mark, that's what we're trying to find. V1, we're going to say equals 0 meters per second because we know that starts from rest. T equals the 0.77 seconds, and then the a is going to be the negative 9.8 meters per second squared. All right, so now we do our equation. So we're going to basically use that equation there, but we can cross off the first part because v1 equals 0. So I end up with d equals 1/2 times a times t squared. Okay. And then we got to substitute now. Zoom in just a little bit here. And we've got d equals, I'm going to say 0.5 just because that's easier to type in your calculator, times negative 9.8 meters per second squared times 0.77 seconds squared. So what happens here now is I got to do my order of operations. So I'm going to take care of this first. So the 0.77 seconds, excuse me. All right, had to take a phone call, but I'm back. Here we go. So this would be 0.5929 seconds squared because that squared squares both of them, times, I'm just going to multiply those two together, so I end up with a negative 4.9 meters per second squared. I'm going to multiply both of these together. The second squared and second squared cross out, so then I'm just left with meters, which is good. Type those into my calculator, and I end up with negative 2.9 meters. So the distance, or the displacement, or however you want to think about it, the apple fell down. That's the negative 2.9 meters. The question's asking for how, let's see, how tall is the tree? So then we could say D equals 2.9 meters. Both of them are correct, so I'll circle them. If we're being technical, how tall is the tree? Well, the tree is 2.9 meters tall. But if you answered negative 2.9, hey, you know what you're doing. So that's all I got. Thanks for listening.